Let's look at a right triangle in which one of the other angles is 45 degrees. Okay, so since the triangle angle add up to 180 degrees, this is 90 and 45, the other one is also 45. Okay, so that means that the angles that are opposite 45 would end up being the same angle, or the same side. So because we have two same angles and two same sides, this is called an isosceles triangle. Okay, so let me just pick a value. It really doesn't matter. Let's say this is 1. So that means the other side is also 1. So if I want to find that missing side, let me call it x. So by the Pythagorean theorem, 1 squared plus 1 squared is x squared. So 2 is x squared. So then x is positive square root of 2. Okay, so from this triangle we can find the 6 trig functions of 45 degrees. So if I have the sine of 45 degrees, opposite over hypotenuse, I get 1 over the square root of 2, or rationalize square root of 2 over 2. Cosine of 45 degrees is going to be the same thing, because the adjacent is the same as the opposite. Okay, tangent of 45 degrees will be opposite over adjacent. So opposite over adjacent, again, they're the same thing, so we're just going to get 1. So now that we have those three, we can just take their reciprocals to find the others. So cotangent of 45 degrees is also 1. The secant of 45 degrees is the reciprocal of cosine before I rationalized it, so that's just square root of 2. And then cosecant of 45 degrees will be the same as secant, because again, opposite and adjacent are the same. Okay, so I did this for the 45 degrees, but keep in mind that this could have been done in radians. So if I want to convert 45 degrees into radians, I would multiply 45 by 1 degree, which is pi over 180. 45 into 180 is 4, so this is the same thing as pi over 4 radians. Okay, so you can replace all these 45 degrees with pi over 4. So let's do a couple examples using these values, because these are going to be really used a lot. So we need to get comfortable with this. So let's find the exact value of maybe the sine of 45 degrees times the tangent of 45 degrees. Okay, so sine of 45 degrees, just something we're going to have to remember at this point, is square root of 2 over 2. But if you ever forget it, feel free to redraw this triangle, and you can find the sine that way. So that's square root of 2 over 2. And then the tangent of 45 degrees, opposite and adjacent are the same, so that's just going to be 1. Let's look at one more. Let's say the cosecant of, let's call it pi over 4, divided by the cosine of pi over 4. Okay, cosecant of pi over 4, same thing as cosecant of 45 degrees, square root of 2. Cosine of pi over 4 is the same thing as sine of pi over 4, because cosine and sine are the same within this triangle. So that's going to be square root of 2 over 2. Here's kind of a weird looking fraction. This is actually called complex because I have a fraction within a fraction. So let me change this over into multiplication of the reciprocal of the bottom. So the square root of 2's cancel. This is actually just 2.